Hey people, welcome to my YouTube channel. Today we are going to build a simple project on recommendation system. So before we deep dive into the project, let's understand types of recommendation systems. Okay, so let it generate. But yeah, there are few recommendation systems. One is content based, and other one is user based recommendation system, and one is hybrid approach. Okay, so we are going to build a project based on hybrid approach. Okay, so yeah, so first let us understand what is a content based filtering. Why I'm not able to say based. Okay, yeah, so if you see, it recommends items similar to what the user liked in the past. Okay, so it is up to you. So what you have liked in the past, based on that it filters the content and it gives you. Okay, and next is collaborative filtering, so it recommends based on other users. Okay, so let's say if your friend, you're using your friend's Netflix account, right? You will see that this is also watched by your friend, something like that at the bottom, and you get recommendation based on that. That is collaborative filtering. And next approach is hybrid based, basically. Yeah, this one. Okay, hybrid recommendation system, it is basically content plus collaborative. Okay, this I'm not sure what it is. Matrix factorization model based filtering, it learns latent features from interaction matrices user item to make predictions. So it is complex. Let's not deep dive into it, but yeah, the basics of recommendation system you need to understand is content based filtering, collaborative, and one is hybrid approach. Okay, so in case of hybrid, we combine both the content and collaborative filtering. Okay, so there are other approaches also, you can look into it afterwards. Okay, so today's project is, we are going to build a recommendation system which gives us recommendation of anime. Okay, using basically the hybrid approach. Okay, so we will see that how it is working behind the hood. Okay, so first thing first, if you see the folder structure, which is in this. Okay, it is recommend.sys. In it, in this we have like different folders. One is data, where we have anime and rating CSV. And if you look into what the data looks like, if you see, we have anime ID, name, its genre, type, episodes, rating, and members. Okay, and in case of rating.csv, we have user ID, enemy ID, and the rating. Okay, so these are the two data sets that you need to know. Okay, and then we have also images folder, which consists of images of that particular anime. Okay, so first thing first, what I did here is to get the anime images. So I filtered out, I mean, I went to this site, Jinkan API, which is like the API call to get the images of whatever anime ID you have in the anime.csv. Okay, so once I filtered out the animes, okay, sorry, once I downloaded the anime images, right? So the folder anime.csv, it has like many animes. Okay, okay, and the list goes on and goes on. So I did not want that much because it is personal project, so I did not want it to load for a longer duration and run for longer duration. So what I did here is, I downloaded a couple of images and couple of animes, I mean related to it, and then I stopped it. But what happened here is, some of the images were not downloaded, even though they were in the even though the anime was there with respect to them, right? So what I did, I wrote another code which basically filters out the anime. Okay, into a new list, that is a new CSV file, which is anime.csv and rating.csv. And with respect to these anime and rating, I have all the images now. Okay, so it is like I filtered out the original data set. That's it. Okay, now don't need to dive deep in that. Okay, so let's focus on our code. Okay, so this is the Streamlit code and this is the recommended.py. Okay, so let's go step by step to understand what it is doing behind the hood. Okay, so first what we are doing, we are importing OS, then we are importing pandas library, and then numpy library. Okay, Now next is anime df data frame, which basically reads anime with images. If you see, this is the filtered data set and rating with images, and we are dropping the duplicates from anime id, and from ratings we are dropping duplicates of user id and anime id. Okay, now image folder is the images folder which we have specified here, and first function is get anime image. So this function basically checks if your folder path exists or not, and then it returns the image path if it exists. Okay, next is what we are getting. We are getting popular anime. Okay, so how many animes we are getting? 5 total. Okay, so what it does is ratings df dot group by, we are basically grouping it by anime id and rating dot mean. So whoever the anime whose rating is highest, we are grouping it by mean, and then we are sorting the values in the descending order, and we are getting the top 5 animes from it. Okay, now if that anime is in that anime data frame, then we are getting that anime with respect to the columns anime id, name and genre. Okay, and we are returning that top anime. Okay, so this is to get the popular anime based on the mean. Now in case of hybrid recommendation, if you see, we are getting the anime title and top n, that is 5. Okay, so once we get into this function, we have collaborative df. Basically collaborative filtering happens here, and we go inside this function. If you see, go to, yeah, definition, this is the collaborative function, sorry, collaborative recommendation. Okay, so what it does is it first checks if anime title not in anime df. If it is not there, then it just returns the empty data frame with the column names. Okay, else it gets that name. Okay, uh, its first occurrence. Okay, values dot zero in this sense, the first of that list. Okay, if anime id not in the ratings, if it is not there in that ratings data frame also, then we are returning the empty data frame again. Okay, next what we are doing a pivot of user id. Basically this is the index, column is anime id, and values are rating, and aggregate function is again mean here. Okay, now what we are doing, we are counting the anime id, the value counts. Okay, who have the anime whose ratings, or who has uh, greater than or equal to 10 ratings. Okay, based on that we are filtering the animes. Okay, so who, okay, if let me take this part of code, because sometimes what I do is I make it more complex, right? So instead, let me give this to GPT itself so that it will explain each line, and it will be easier for us to understand, right? Okay, let it generate. So the basic context is, once, if if you see here, if the collaborative filtering, if it is greater than or equal to top n, that means if the collaborative recommendation is giving 5 enemies, okay, we are keeping it as it is and we are returning those enemies as the recommendation. If not, we are getting the popular enemies basically based on just the mean. But here in collaborative, what we are doing here is, in short, we are comparing it with the ratings with respect to two users, and if it has I mean, we are including Pearson correlation coefficient in this. Okay, so we are comparing those two things, and then we are getting the enemies. Okay, so let's head back here and let's see the explanation. Okay, let me close this. If you see from the try block, I think I gave it. Yeah, where is the try block? Okay, let's see what it is giving. If you see user matrix ratings dot df dot pivot table, so creates a user item matrix where rows are user id, okay, and columns are anime id, okay, and values are mean rating each user give to each anime. So mean of rating which each user gives is taken here. Okay, and missing ratings will be none, not empty value. Now what these three lines will do here is, it filters out animes animes with fewer than 10 ratings uh, to avoid basically the redundant things, and keeps only those anime IDs in the matrix that have enough data. Okay, and if the input anime ID not in the matrix, return an empty data frame. If this input anime ID is not in this user item, that matrix that we created, then we return an empty data frame. Okay, and this what it does is, and this helps to normalize behavior. Example, uh, basically it removes the bias of users. Let's say some users rate any anime like 5, either high or low, based on their ego or self satisfaction, right? So that it normalizes here. Okay, basically. Now what we do here is, in target ratings, what we do, we get the ratings of the target enemy, uh, dropping users who haven't rated it. Okay, and if fewer than 2 users rated them, then also there is no enough data, we return the empty data frame, and then we loop it to calculate the similarity with other enemy. Okay, in this format. Now get the ratings of the current anime being compared. Now this other ratings is comparison with the anime which we filtered out. Okay, and find the common users who rated both this and target anime. Okay, so these two lines. Now next is, if at least 2 users rated both animes, we compute the Pearson correlation between the two sets of ratings, and this np dot error state is used to suppress warnings due to divide by 0. So this divide by 0 error it suppresses. Okay, and save the correlation score only if it is valid and non-zero. Okay, so this is what it does, and if no valid similarities, we return the empty data again. Okay, and then we sort it by highest similarity. If you see, it is in reverse. Okay, reverse, it is true, and we pick top 10 similar anime. Okay, and finally it gets applies the image path, and we get that anime, and finally we get the recommended anime. Okay, this is in case of recommendation. Okay, so that means collaborative filtering, which is like the based on the users, and popular is basically directly with respect to the ratings mean. Okay, so two approaches we are using here, and finally we are giving the recommendation. Okay, so if there is some error or exception, we are returning just again the empty data frame. Now if you see our streamlit interface here, we are first setting anime recommendation. Okay, let me run this instead. Okay, streamlit run app.py. Okay, so let it run. Okay, enter anime name, it is saying. Okay, so Naruto, I was testing it. So if you see anime recommender, okay, so this is what it is doing here, anime recommender, and we are asking us to get the input, which is this enter anime name. So if you see, enter anime name is here. Okay, and it suggested also. Now recommendation of Naruto. Okay, so these are the 5. If you see, we are getting 5. Also the images also we are getting. Okay, and it first goes to get hybrid recommendation, which is, if I go to definition, it goes here, get hybrid recommendation, and finally it goes to, so anime title is what we type here, that is Naruto. Okay, so based on that, it filters get collaborative recommendations, and if uh, length of this is greater than or equal to 5, then it directly suggests that, else it goes to this get popular anime, if you see from here. Okay, and now if I, let's say, Kimi no Nawa, if I take this and paste it here, will it run? Yeah, so we got these recommendations. Okay, according to you, you might think that these are not the enemies which are like Kimi no Nawa, but if you see, our data set might not have the enemies which you are thinking might similar to this, right? So pardon the anime data frame here. Okay, so yeah, I think that's about it. So if you see, if recommendation empty, we get this message, else we get columns are 5. So these are the 5 columns basically, And if you see image path, this is basically the setting up of image, whatever we see here. And markdown is name. If there is no image available, it gives this message. And genre, if you see, this is the name and this is the genre what we are getting for every anime. Okay, so hope you learned something from this anime recommender. I know this is like the base project which people do. I was like, I wanted to try something new, but yeah, to cover the basics and to understand in depth something, I tried to build this simple project. Okay, so this is for the people who are trying to upskill in the data science domain and who are new to this domain. So they might feel this interesting, not for the folks who are like elite, who are big shots in this field. Okay, so this is like very simple project for them. So don't judge me here. Okay. Anyway, this is for the people who are new to this field, and yeah, people will get it. So hope you learned something from this video. And if you do, do like, share, and subscribe. And until then, take care. Bye bye.